For those of you from outside AAAS, welcome. We're happy to tell you more about AAAS, the world's premier general science membership organization. And we do a number of things in science and society, science education, science and the law, in addition to our publishing. And as you'll hear tonight, I'm sure Jane will refer to some of her introduction to this work years ago here at AAAS. We work on seeing that science is well integrated into policy. Tonight's lecture is the Robert C. Barnard Environmental Lecture. And let me say a word about the person in whose honor this lecture series is held. It's sponsored by the international law firm of Cleary Gottlieb, and it honors a former counsel in that firm for his contributions to environmental and public health law, and in recognition of his many years of service as a member of the selection committee of the AAAS Science and Technology Policy Fellowships. We used to have, well, we still place many policy fellows at the EPA each year as part of the 250 PhD level scientists that we place throughout all three branches of the government. And there was a slightly different program, a similar program, placing fellows at EPA some years ago. And Mr. Barnard was a selector in that program. And sponsored by his former firm. Our distinguished presenter this evening is Dr. Jane Lubchenco from the university. She's from Oregon State University, where she is the University Distinguished Professor and Advisor in Marine Studies. She is also the U.S. Science Envoy. This is something created by President Obama, and she's the most recent in the series of science envoys. She is envoy for the ocean and resides in that role at the Department of State. You can read her full bio in your program, but she's had too good a career to for me to let it go by. I'd like to say a few words. I think, like many of you, I knew her by reputation long before I met her for her work in environmental science, in marine biology, in biodiversity, in climate change, and interactions between humans and our environment. She's been very active in a number of ways. She was Undersecretary of Commerce for Oceans and Atmosphere and Administrator of the National Oceanic and Atmospheric Administration from 2009 to 2013. Following that, she was Distinguished Visitor in Public Service at Stanford University. That was in 2013, and is currently Distinguished University Professor at Oregon State. You may have seen her some years ago listed as a MacArthur awardee, the so-called Genius Award. In her case, I think it applies. A Pew Conservation Fellow. She's also won the Heinz Environment Award, the Blue Planet Prize, and the esteemed Tyler Environmental Prize. She is not someone who rests on her laurels. These are awards for past accomplishments, but she's continuing to travel the world now as U.S. Envoy for the ocean. She founded Compass. She helped found the Leopold Leadership Fellowships, and PISCO, the Ocean Research Consortium. And I'm pleased to say that in 1996 and 97, she was president of AAAS. I figure she must have been one of the youngest presidents AAAS ever had. As Barnard Lecturer tonight, she follows in a line of illustrious speakers. The current science advisor to the president, John Holdren, was a Barnard Lecturer, as was Nobel Peace Prize laureate and president of Costa Rica, Oscar Arias. Andrew Revkin, the New York Times award-winning journalist, gave the Barnard Lecture, as did Heidi Hackman, executive director of the International Council on Science. Tonight, Dr. Lubchenco will speak on returning science to its rightful place, and we are glad to welcome Jane Lubchenco back to her rightful place here at AAAS.
Thank you so much, Dr. Halt. I've known him under many titles over many years, and I'm just delighted that he's here at AAAS. It is a great pleasure for me to be back in this building. When I was on the AAAS board as president-elect, as president, and then as chair of the board, we designed and then constructed this building, and I had the pleasure of cutting the ribbon. So it's really wonderful to be back here and see what a vibrant place it is and how many great things are going on here at AAAS. I want to begin by thanking the committee as well as the sponsors for the Barnard Lecture. It's really a great honor to be selected for this, and thank you all so much for coming out tonight. I know there are hundreds of things going on, and it means a lot for me to be here with you. We've got some technical challenges here. I'm going to have to figure all of this out as we go ahead, but I'm deeply honored to be here with you tonight. We've all heard the phrase, returning science to its rightful place, but what does that actually mean? What does it mean to you? I'm going to share a little bit about what it means to me. And I'm going to focus a little bit about what our responsibilities as scientists are for ensuring that, in fact, we understand what science's rightful place is, and we are actively working to do that. So today, I'm going to be sharing my reflections. Those reflections are firmly, it'll take me a minute to get organized here. My reflections on this topic are highly colored by a number of different experiences that I've had personally, both my experiences as an academic marine scientist for a number of decades, but also my experiences as administrator of NOAA for 4 years, the first 4 years of the Obama administration, and as a member of the president's quote-unquote science team. As administrator of NOAA, I spent a lot of time with the talented scientists at NOAA, generating scientific knowledge, sharing that knowledge with the public and with members of Congress, other elected officials, but also using that knowledge to provide both good stewardship for the oceans and coasts, as well as services, for example, climate information to the public. We had a considerable range of experiences during the time that I was there. But one of the roles that each of the members of the science team played was also to share scientific information with other members of the administration, both elected officials, members of the administration, elected officials such as folks in Congress, but also other political and career appointees in other kinds of jobs within the administration, whether it was national security or removing of dams and restoring habitats, the oil spill disaster in the Gulf, or climate change. We are actively engaged. I also spent a lot of time with elected representatives, both in Congress as well as in the state houses around the country, providing, for example, the first demonstration, the first live demonstration of ocean acidification in a congressional testimony at Congress, but also talking sometimes endlessly, having endless hearings on climate change and on the oil spill, but also providing hurricane forecasts and much, much more. My students used to joke with me that they thought I was particularly well prepared as a marine biologist for the rough and tumble world of politics in DC, because I already knew how to swim with sharks. But in truth, my interest in communicating science also, I think, came in very, very handy in all of these interactions with non-scientists. Although I think I was not completely prepared for a number of the interactions that we had. And I remember very distinctly, for example, one time when I was speaking with a very key member of Congress about how important NOAA's weather satellites are, how important it was to fund them, how they provide over 90% of the data that go into our weather forecasts. And he just looked at me and shook his head and said, "Doctor, I don't need your weather satellites. I have the Weather Channel." And I thought, okay, a couple steps back, let's explain where the Weather Channel gets information. So all of these experiences during the 4 years I was here in Washington gave me new insights into the role of science in the federal government and in our society. Those experiences have been even more enriched by my experiences as the U.S. Science Envoy for the Ocean, traveling to a number of countries, but focusing specifically on some in Asia, Indonesia, and China, and some in Africa, South Africa, Mauritius, and Seychelles, and focusing on ocean issues for sure, but in particular the blue economy, because many of these countries are actively looking at how do we create more jobs, how do we get food security, how do we achieve poverty alleviation by looking to the ocean, and new technology is allowing us to use the ocean in ways that we haven't. And so the question is how to do that sustainably. How do we use the ocean without using it up? And science can help understand what some of those trade-offs are and help inform the understanding and the decisions made about those. So based on those experiences, I come to this question of what is science's rightful place? What is that rightful place? And how should we think about that? Now, I want to focus initially on the rightful place of science in the federal government, but then expand that to think more broadly about the rightful place of science in society more broadly and in our daily lives. And I'd like to invite you to think about what is your role in achieving whatever we think is that appropriate role for science. So let's dive in and focus first of all on the rightful place of science in the federal government. So I'm getting confused here, sorry. About a decade ago, there was considerable evidence accruing that there had been very explicit manipulation of scientific information by members of the Bush administration around the topic of climate change in particular, very well documented. And as this became better and better known, there was considerable angst about this within the scientific community, within Congress itself, with members of both parties about the manipulation of science. And so there was a lot of focus on scientific integrity. And a number of things happened, one of which was this committee of the House of Representatives on Oversight and Government Reform spent 16 months doing a very exhaustive investigation of some of the accusations, and they concluded that there in fact was good evidence that there had been considerable suppression, manipulation, distortion, cherry-picking of scientific information, and that that was really unacceptable. That led in part to a much more intense focus on scientific integrity as a topic, and to the importance of restoring scientific integrity to the federal government. This took on a number of forms. During the election in 2007, 2008, a very active group was formed, Science Debate 2008, which now has a new reincarnation. But they were really providing science questions to the candidates and to the parties and inviting them to take positions on scientific issues, but in general, but scientific integrity much more specifically. And the Democratic Party posted what you see up on the slide as part of their platform on their website, with a very explicit focus on restoring scientific integrity to government and exactly what that meant. By the time of the 2008 elections then, some candidates and some parties had taken public positions, and in mid-December of 2008, after President Barack Obama had been elected as president, he in fact began immediately to act on his promises and those of his party to focus on scientific integrity in amongst the range of other things that he was focused on. And so in mid-December, right after nominating most of the members of his cabinet, President-elect Obama announced with great fanfare his science team. And I think this was the first time that at least I'm aware of that a president had a science team and was really drawing attention to it. And so that obviously consisted of a number of individuals. This was the cartoon that was published by The Economist magazine a few months later, really drawing attention in a very public way to this science team. But in addition to the president, there was John Holdren as his science advisor, Steve Chu, who had already been nominated as the Secretary of Energy, Harold Varmus and Eric Lander, the two co-chairs of the President's Council of Advisors on Science and Technology, along with John Holdren. And you can see that each of them is holding something appropriate to their disciplines. And here I am holding a little aquarium as the marine biologist of the team. So this announcement was really extolled by the scientific community, but the public more broadly, as exemplified by this particular cartoon. The president continued to act on this, and in fact, in his inaugural address on day one, January 20th, he said, "We will restore science to its rightful place." Within the first 100 days, he acted very aggressively with all the other things he was doing, not to mention trying to think about how to put the economy back on track, but really focusing on scientific integrity, issuing a memorandum that said very explicitly to each of the heads of the agencies and departments, you must create a scientific integrity policy. Dr. Holdren is going to lead that process, and I want those scientific integrity policies to abide by the following principles that he enumerated. And those included science and the scientific process must inform and guide decisions. The public must be able to trust science and the scientific process that informs public policy decisions, and political officials should not suppress or alter scientific or technological findings and conclusions. So within the first 50 days, he did that. Day 97, he joined the members of the National Academy of Sciences at their annual meeting, and he developed this theme even further about scientific integrity and the role of science in his administration. So promises before he was elected, and then as soon as he was elected, he began developing what that actually meant. Now, I know that John Holdren has a very rich talk that includes lots and lots of things that the president has done to restore scientific integrity. I'm not going to repeat all of that John says, but I want to go into a few of the things and then broaden this topic to not just federal government, but to society more largely. So to do that, I want to just note that most of the agencies now have scientific integrity policies. I took this very seriously when I was at NOAA. We had a very deliberative and inclusive process of developing NOAA's scientific integrity policy. It was not my policy, it wasn't the administrator's policy, it was NOAA's policy. And it was a very bottom-up exercise. Many of the career folks at NOAA had been through a variety of administrations in the past, knew what worked and what didn't work, and brought those experiences to bear in creating a policy that we then opened up for public comment. We shared with other agencies. It was a very, again, deliberative and inclusive process. And it was a very public process. And so I think the end result of that process was not just a good, robust policy that has been called by others the platinum standard of scientific integrity policies, but in fact, it was one that is much more likely to be durable in future administrations because it's owned by the folks at NOAA and because it was done so publicly. So the process, I think, was very important to ensuring that it has legs beyond a particular administration. NOAA's scientific integrity policy focuses on a couple of key things. Like most of the other agencies' policies, it says explicitly that it is forbidden to manipulate, suppress, or cherry-pick scientific information. That is verboten, and there are processes in place to prevent that from happening. But different from most other agencies' scientific integrity policies, it also says that scientists at NOAA are free to talk to the media without going through a public affairs official, without going through a gatekeeper. It's fine if scientists contact the public affairs officers and say, whom should I talk to? But the press can talk to anybody, and the scientists can talk to anybody outside the agency about their science. And I believe that that is the right thing to do. It is distinctly unusual for most scientific agencies. I think it should be more routine. But I can tell you that my colleagues in other agencies said, you're going to regret this. This is a really bad idea. And I said, well, let's wait and see. I'm going to trust my scientists, to make it clear they're not speaking for the agency. They are speaking about their science. And as far as I know, that has continued to be honored, and it has worked very, very well. I can also tell you that there were a number of journalists who immediately called up scientists at NOAA, and sure enough, they could talk to them. And a number of them came up to me, one at a AAAS holiday reception later that year, and said, my gosh, I couldn't believe it. I got through. I could talk to them. This is fantastic. Thank you. So I think it really was a breath of fresh air and a time of renewal and empowerment of scientists. Just having a policy is not enough. It has to be a living policy, and you have to have other things in an agency that allow for good career paths for scientists, such that they're promoted for their science, not just for being a good manager, for example. And there is room to advance, and there is good outside advice to scientific agencies. So there are a whole suite of things that go along with having a good scientific integrity policy. But I think those are key and important. So thus far, we focused on scientific integrity. But I want to talk a little more broadly about the role of the federal government in science. And this is nothing new to any of you, but I just want to use it as a touchstone. Enabling scientific discovery is a key thing that the federal government does for the scientific enterprise. It's not unique to the federal government, but the federal government has a key role to play in that. Protecting scientific integrity is equally important, and that is both with respect to in-house and outside scientific expertise, and protecting it from manipulation, distortion, cherry-picking, suppressing that we've been talking about. Above and beyond that, and highlighted by some of the President's principles, it's also important for the federal government to share data and information, to educate citizens so that there's transparency as much as is possible, and very importantly, to use that scientific information to make policy decisions. Now, no one would tell you that policy should be based only on science. There are a range of other important considerations. They might be political, they might be economic, they might be security, there might be values and beliefs that are important. But my point is that science should be at the table, and there should be explicit mechanisms for saying, what does the science say? And in fact, when we were dealing with the oil spill disaster, every single call, we had daily calls, sometimes twice a day, among the principals who were dealing with the oil spill. So that was the Secretary of Homeland Security, the National Incident Commander and Commandant of the Coast Guard. It was the Administrator of EPA. It was the Secretary of the Interior. It was a senior advisor to the President and me. And every one of those calls, Thad Allen, who is the National Incident Commander, would start with, what does the science say about whatever the topic was we were dealing with that day? So that, just as a single example, was often the case in many meetings that I was with other people in the White House, asking explicitly, what does the science say about this? And then making decisions, taking that into account. But I want to emphasize that decisions are going to be based on more than just science, but that science should be at the table. So I believe that during the time I was at NOAA and since then, we did indeed use good scientific information to make our policies, make our management decisions. We spent a huge amount of effort trying to share scientific information, make it as transparent as possible. And NOAA, as a science agency, really has a mission of science, doing science and using science in support of its stewardship and service responsibilities that are mandated. That's true across all the different issue areas that NOAA works with. And I'm really, really proud of the depth and breadth of the science at NOAA and the extent to which it really does inform NOAA's policies and practices. So again, I've talked about the rightful place of science in the federal government, focusing on scientific integrity, but a little more broadly than that. I want to think a little more broadly still and focus on the role of science in society. And especially in this year, this election year, in conversations, in debates, and some of the unprecedented craziness we've seen, it's pretty obvious that we are fully in the midst, we are fully immersed in what some have called a post-truth society. Like it or not, there's pretty strong evidence that there are people who do not hold the same value, at least I do, for evidence, for scientific information, for data. And like it or not, that's a reality. And so the question is, how do we as scientists think about that? How do we deal with that? How does our role change in light of that knowledge? It behooves us to be very conscious about this challenge. And this brings me to what I call the science-society paradox. I believe that, in fact, this is a time when science is more relevant to society than ever before in history. It is so important. And yet, at the same time, there is a widening gap between science and society with respect to at least many key issues. So, why do we have this paradox? What's causing it? How do we deal with it? I would suggest that there are three important bins that we need to think about, because not all science is the same. One is the perception of science in general. The second is the attitudes of the public towards specific issues for which there's scientific information. And the third is the public perception of scientists themselves. So let's focus on the first and think about what are the perceptions of science in general. And if you look at polls, there's pretty good information that the public in general thinks science is important. They think science does useful things. It's improved our lives. So if you ask people about science in general, it's pretty good. It has been getting less positive through time, but it's still pretty good, okay? So on some issues, however, there is a huge gap between what scientists say and what the public say they believe. And one of those areas is climate change. And in climate change, as most of you are well aware of, there is quite a significant gap with respect to what people say and what people say they think science says and what the science says. So this is a challenge. Now, with with climate change and with some of the other issues, we have very good evidence that there has been a concerted, organized, orchestrated campaign to sow information, to sow doubt and confusion. So we have to acknowledge that that is out there, and that makes this challenge even more difficult. But that's not true for all of these issues. With GMOs, for example, there is also a considerable disparity between what scientists think about GMOs and what the public thinks about GMOs. With respect to evolution, there's been a lot of information about that. 98% of scientists agree that humans have evolved, but only 65% of the general public agrees. So again, we have a gap here. With respect to vaccines, there is also a disparity. Although in this case, it's interesting, there's a disparity between what people say they believe and what they do. And so there are a lot of nuances in each of these different issues that we have to confront. And so these are complex. There's no single silver bullet with any of these. So why do we have this paradox? I focused on the perception of science in general, very positive. Certain particular issues often conflict with people's beliefs about things, and so there's a disconnect between the evidence and their beliefs. But let's turn to this third issue, which is how the public thinks about us, how the public thinks about scientists. We know a lot from the great social science work that's been done in this area, and I want to highlight the work of two scientists, two social scientists in this regard, who really have focused on the perception along two axes. There are two axes on this figure. One is warmth, and one is competence. And this is the work of Fisk and Dupree. And what they are suggesting is that for an individual to be trustworthy, they need to be seen as both warm and competent. Warm and competent. Scientists are generally way, way off to the side on competency. There's no doubt they're competent, but they're seen as being cold. Scientists are competent but cold. And because of that, according to these social scientists, many people don't trust scientists. They might believe they're competent, but they don't trust them. That's a problem. That's a real problem when it comes to communication. So you can see here that the researcher and scientists are here. You can look at what all these other categories that they evaluated for how people think about them. At least researchers and scientists are more warm than lawyers. I tell my sister who's an attorney. But I think this is a really insightful finding that we need to take to heart. And this is something that scientists can do something about. When we train our scientists to talk, we train them to be very neutral. We train them to focus on the facts. We train them to strip away any of their humanity. And in fact, that's just the opposite of what makes them more trustworthy in the eyes of many non-scientists. So this is something that we can actively address. We also know from other social science work that, my clicker is not working. I know you're hanging on every word here. Okay, so let's see if we can go backward, forward. No. Okay. When my clicker at home on my machine doesn't work, that didn't work either. Oscar, are you? There's a keyboard tray. Where is the keyboard tray? Keyboard tray here. Okay, we'll try this. Page down. Oh, yay! Okay, thanks, Cynthia. Okay, we also know from other social science research that people's perceptions of scientists change once they come into contact with real scientists. And these are some experiences or some perceptions, drawings of scientists that were done by 7th graders. And they were done before and after they visited Fermi labs. And so before they visited Fermi labs, this is what they thought scientists looked like. 95% white, 90% male, 71% with wild hair, and they were in lab coats and glasses. So that's sort of the perception. After they had been to Fermi labs, then they had a different idea of what scientists were, just by virtue of personal experience with them. So one of the lessons from this is that, in fact, many people don't come into contact with scientists, and so they have these stereotypes. And when they hear about scientific findings, they think they're generated by the folks on the left, whom obviously aren't trustworthy or something. And so this again is something we can do. And many of you have had calls from all sorts of middle and high school students having to interview a scientist. Well, I think that's one great thing that teachers are doing, is trying to make scientists more accessible and more personal and personable to their students. So scientific information is helping us understand some of this science-society paradox. Oops, sorry. Another element of this, solving this dilemma, is the fact that we also know from research that who a messenger is often more important than the message. And so messengers like Katharine Hayhoe, who is a very public and very committed evangelical Christian, who is also a climate scientist. She has opened up avenues of communication with other Christians with whom she shares many of the same values that would not be possible avenues of communication for other scientists. And so I think, and much of the social science research that's been done, for example, by Skip Lupia at University of Michigan, is emphasizing the importance of establishing common values with an audience as a way of gaining trust and being perceived as being warm, and then having greater opportunities for actual exchanges of information and views. So all of this information, I think, is important in helping us understand what this paradox is all about and how to resolve it. I would suggest that resolving the paradox means, first and foremost, understanding it. I didn't put that up there, but I should have. Understanding that paradox, but then engaging with society in a meaningful two-way direction, learning to communicate better, showing your warmth, and showing how science can be helpful to society, not just identify problems. And so the public's perception of scientists is also colored in part by certain topics. The public thinks that cell biologists and molecular biologists like to play God. The public often thinks that environmental scientists, such as myself, All we do is say doom and gloom. We're never suggesting any positive solutions. All we're doing is say it's bad, and things are going to hell. So understanding how we are seen and changing what we do to communicate differently and to focus on solutions are elements, I believe, in resolving this paradox. When I was president of AAAS, for my presidential address, I really focused 20 years ago almost now, 19, on what I saw as grand challenges for science, and suggested that we needed to negotiate a new social contract with society where we would pledge in exchange for public funding to engage with society, to share knowledge more widely than we do, not just at scientific meetings and with our colleagues, but with the public in a much more aggressive fashion, focus on the most urgent problems of society and help design solutions, and to be more obviously humble and transparent than in fact is either we do or is the perception. I think we've now, in these 20 years, made a segue from social contract to a moral imperative to do many of these things in light of this science-society paradox that I've identified, in light of the need to return science to its rightful place in society. And I think that, in fact, much of this is beginning to happen. It's just not happening at the scale that we need it to. So investing in understanding the public, I think, is a key element of resolving these challenges. Training scientists in communications, making science more accessible, more interesting, building the infrastructure for engagement, meaningful engagement with society, and embracing use-inspired science, and unleashing and empowering young scientists who get this and who are anxious to pursue this, but they often feel that their seniors are saying, no, don't do that, focus on your science. So I think there are a whole range of things that are beginning to happen, they're just not at the scale. So let me say a little bit more about each of those recommendations: investing, training, making science accessible, et cetera. Investing in understanding the public and in understanding what they want, what they need, what they believe, what they value is very much a two-way interaction. A lot of scientists think about communicating as telling them what I know. And we need to realize that, in fact, it really is two-way. And, in fact, many scientists that I know that actively engage with society get all sorts of new ideas about things that they could work on based on what was identified by non-scientists. And so it really is spurring new science. It's a rich avenue for new scientific discoveries. Training scientists to communicate better, doing what I call becoming bilingual. I believe that scientists should speak the language of science, but they also should learn to speak the language of lay people. That's what I mean by being bilingual. And some scientists do that very, very well. Others can if they are trained. Not everyone wants to or should necessarily be a public communicator, but all of them should support those who do and should encourage their students to do so if they want to. There are a wealth of communication trainings that are available now that have popped up in the last 20 years. Rush, in his introduction, mentioned Compass and the Leopold Leadership Program, both of which I co-founded, also Climate Central. But other AAAS now has its program. The Alan Alda Center has its program. So there are a number of opportunities, but they aren't at the scale that are needed yet. Graduate students, undergraduates say over and over and over, where do I get this training? Many academics, many agency scientists want training and don't have an easy way to get it. So there's a rich opportunity there. In addition to that, I think we can make science more accessible to the public. And again, there's a lot of new good stuff that's going on. The BioBlitz that National Geographic is doing, a lot of programs that AAAS has, a lot of universities now have programs around citizen science and making science more accessible. A lot of scientists are embracing them. It's not yet at the scale that it needs to be. Building infrastructure for engagement is a really ripe opportunity. Recognizing the value of engagement, creating, this is building bridges between natural scientists and social scientists to figure out how to do this effectively, and getting funding to do it, which is not always easy, are some great opportunities. Unleashing the creativity, the power of students, I think is a wonderful opportunity. The Dance Your PhD competition was just finalized, and the winners were just recently announced, and that's a very good example of that. But so too are other ways of expression through social media, through other things like that. Finally, embracing the potential for science to propose useful solutions. And I'm increasingly convinced that scientists are still stuck in the old framing of there's basic science and there's applied science. And Donald Stokes has told us, in fact, no, there is actually a third category, which he calls use-inspired science, which is advancing fundamental knowledge, exactly like basic science does, but also addressing societal problems. So use-inspired science as a third category that does not get the recognition that it deserves. Increasingly in the biomedical world, there's talk about translational science. That's another word for this, but it's not a word that is used by environmental scientists. And so we're sort of talking in two different worlds here, and there's a very rich arena for use-inspired science. It is as important, as valid as curiosity-driven science, but it still is not sort of given its due in my view. The new UN Sustainable Development Goals that are charting the agenda for the international community for the next 15 years provide a rich array of societally relevant opportunities for science to be engaged, to be helpful. Many of you are already involved in the science behind some of these, but there are ample opportunities to be even more involved. Within Goal 14 of the Sustainable Development Goals, Life Below Water, let me give you two very brief examples of use-inspired science that has evolved over the last 20 years that is just transforming the landscape in the ocean arena. So I'll start with the very simple reminder that marine ecosystems provide a wealth of benefits to people. Food, oxygen, half the oxygen you breathe has come from the ocean. Medicine, fuel, climate regulation, disease, pest regulation, coastal protection, cultural and spiritual values are all really important benefits that we get from the ocean. However, a variety of activities, including fishing, habitat loss, pollution, and now climate change and ocean acidification, disrupt and deplete ocean ecosystems, and they are threatening the benefits that those systems provide. Ocean are increasingly threatened by climate change and ocean acidification, and that presents even greater challenges. Zooming in on fisheries for just a quick moment, this has been one of the toughest challenges globally and one of the most important. It's important to recognize that 1 in 7 people rely on fish for their daily protein. So it's hugely important to food security in the future. When you think food security, don't just think grains and livestock. Think fisheries and aquaculture, because that really is going to be the key. So it makes it even more important that we figure out how to fish sustainably. Our track record in the ocean has not been very good. This figure is FAO, Food and Agricultural Organization, information provided by countries from the year 1950 to 2010. This is percent of stocks developing, fully exploited, overexploited, or collapsed are their categories. And you can see that in 1950, almost all of the stocks were developing, and there were none that had collapsed and none that were overexploited. By the year 2000, over half of them were fully exploited, or actually 2/3 of them fully exploited, or developing, and a vast number collapsed and overexploited. So in a very short period of time, we have gone from rich, bounteous oceans to ones that have been significantly depleted. Congress recognized this, NOAA recognized this, and scientists recognized the importance of dealing with this issue, and have put in place in the US some very important changes that have made it possible to do a 180-degree turnaround in fisheries, such that, I'm going to compare 2 years for you, the year 2000 and the year 2015. In 2000, we had 92 stocks that were overfished. By 2015, thanks to the new law and new policies, much of which happened under my watch at NOAA and is continuing, we have slashed that number to 29. The number of rebuilt stocks has gone from 0 to 39. That's really impressive. That's the number of stocks that have been depleted so that the fishery had to be closed down, have now been rebuilt to the point that they can again be fished again sustainably. So this is an incredibly important good news story that really hasn't gotten a lot of attention, but is just an astounding turnaround that shows, in fact, that the ocean is resilient. If we do the right things and we do them soon enough, there can be hope. Much of that change has come about because of some new ways we manage fisheries called rights-based plans, and there have been an increase in both the number of plans and the number of stocks that, in addition to the very tough teeth and timetable rules that were put in place by Congress, this is a very good news story. This example, this turnaround, has inspired other nations to reform their fisheries. The EU reformed its common fishery policy and is on a much better path. And in fact, many of the large-scale fisheries around the world are on track to become better and better. The small-scale fisheries remain a challenge, but the point is, this was use-inspired science that has actually completely transformed fisheries and is making an incredible difference. Marine reserves is my second example of use-inspired science. These are fully protected areas in the ocean where no extractive activities are allowed. And in fact, they serve a very important role protecting biodiversity, protecting habitats, providing climate refuges, and in many cases, reseeding areas where fisheries have been depleted. We've developed new science that has been in support of where do we need them, how big, how many, how should they be designed, and that, in fact, knowledge has been employed to have huge impact. In the United States, for example, President Obama, when he came into office, there was 6% of the U.S. exclusive economic zone that was strongly protected. And now, with the creation of Papahanaumokuakea in the Northwest Hawaiian Islands, the largest protected area in the world, 2 times the size of Texas and 4 times the size of California, and with the expansion of the Pacific Remote Islands Marine National Monument and the only marine monument now in the Atlantic, those 3 things have now put the U.S. up to over 25% of its EEZ that is protected. If you look globally, the fraction of strongly protected areas around the world is only at 2%. So there's a long, long way to go. But in fact, it is possible, and there's increasing momentum, in part because there's good scientific evidence that they work, and we know how to establish them. So can we return science to its rightful place in the federal government, in society, and in your life? I think we're seeing that it is possible to use good science in formulating federal policy. And I can tell you that this administration has done that. I've given you just a few examples, but there are a lot more. It is possible to restore scientific integrity to the federal government. And it's my belief that even in this post-truth society, we, scientists, all of us, can and should build stronger bridges with society. To do that, we have to resolve this science society paradox. And we can do that by showing that we are warm as well as competent. We can learn to be bilingual. We can co-produce knowledge with users so they have greater trust in our results. We can invest more energy in producing solutions to society's grand challenges. I believe that evidence and facts do matter, but so too do values and beliefs. And we need to figure out how to accommodate both. But to have those values and beliefs informed to the strongest possible way by the evidence and by facts. And that's a challenge to all of us. And so to any of the AAAS fellows who are here in the room, in particular, I would say, it's your turn. We can do this. We can do this together. We've learned a lot about what the problems are and how to solve them. And I think this is an incredibly exciting time to be in science, but in particular, science here in Washington, D.C. And I thank each of you for what you are doing to think about, understand these challenges, and to be helpful so that science is truly serving society. Thank you very much.
To draw a trusted scientist, she would look a lot like Jane Lubchenco. There are microphones on the side. Jane has said she would be happy to have your comments and questions. Please identify yourselves if you would, out of courtesy to others, and also out of courtesy to others, please keep your comments and questions brief.
You say that scientific integrity is on the rise, but how do you explain that in the face of the rise of science lobbyists and even a recent story in March 2015 at the USDA of 10 whistleblowing scientists claiming that their work was ordered redacted, withheld, and stage managed by these powerful industries?
I don't begin to suggest that we have no problems with scientific integrity. They have not all been solved. What I'm suggesting is that at least the agencies with which I'm more familiar have good, robust policies in place. Those policies still have to be made operational. They have to be implemented. And they need to be more uniform across all agencies. So I believe there's still a lot of work to be done, and there will always be challenges and threats. And we need to, I think, stand up to those and say this is really not acceptable. The whistleblower protection is really important to enabling good reform to happen in agencies. And that was one of the things we spent the most time on with NOAA's policy, was trying to figure out what the process should be to adjudicate the very complicated assertions that might be made in any particular direction, and to come up with a solution that is actually fair as well as returning scientific integrity. So I fully admit there are problems that are still out there, and I think we need to be vigilant and tackle them. Yes?
Hi, I'm Todd Peterson with EPA. We look at a world with climate change, but climate change is not a respecter to borders, and yet you've probably interacted with a number of countries. So when you talk about science and informing society, what about your experience with informing across those borders with different nations and how science is speaking to different societies?
Yes, thank you, Tom. Many of the issues that I touched on are, in fact, are global challenges. And they vary hugely from one country to another. What plays out in Europe is really different from what plays out in especially countries that aren't democratic, for example. But that's partly where political leadership, in concert with good science, is so incredibly important. And the importance of President Obama and his team in the diplomacy they did with, for example, China and India, the importance of that cannot be overestimated. I think it was really key. For China to come along and be a very strong partner in both the Paris Agreement, but also the Montreal Protocol, new negotiations with HFCs, both were an issue of partly of science, but partly of very practical considerations for air pollution in China affecting the citizens who are getting increasingly upset about that. So with that particular case, I think that there is a confluence of science and public policy that was enabled because of good diplomacy that has really brought us to a better place. Lots of work yet to be done, very, very complicated challenges ahead with the Paris Agreement, no doubt about that. But I think international diplomacy is incredibly important in addition to good science, and having good science that's out there. And one of the benefits of something like the IPCC is that it is international, and there's an international group of scientists, and they actually talk across borders. And when I was at NOAA, and when John is and was at OSTP, those connections among scientists across borders can actually happen in a different level and have a different conversation than what the political leaders are talking about. So scientists can communicate with one another, and we did, even when our bosses didn't necessarily agree about something, and that can be very powerful as well. Yes?
Mike McCracken from the Climate Institute. I want to ask, get your views on two, it seems to me, problematic words or word roots. One is the word skeptic and skeptical, and the other is the word belief.
Is what?
So, is belief and belief.
Belief. Mm-hmm.
So on skeptics, students are all taught in science class, be skeptical.
Right.
Don't accept anything until you understand it and you've asked all your questions and understand it. Mm-hmm. On the other hand, in the climate change debate, there's this claim about there are skeptics and there's criticism of skeptics, and there was a wonderful report back from the late Bush administration by the staff of the House Science Committee, Democratic staff, which was a report entitled "A Dip into the Skeptic Tank," or something like that, to really sort of portray skeptics as bad, and yet we tell scientists to be skeptical, and we tell young people to be skeptical. On the other hand, the other word is belief and believe. Saying that scientists believe something, it seems to me, is particularly problematic, but I don't know what the alternative is. What you really want to say is scientists are convinced of by the evidence of, which is a longer phrase. And we really should do it. And yet, when you go out and you look at surveys, including ones from the AGU, they asked the members, do you believe in climate change? An answer from a scientist should be no. I'm convinced by the evidence of science. And that word really seems problematic. And I think communicating with the public on those two issues is very difficult.
So Mike, thank you for that, and thanks for all that you've done in this very important arena of science communication and climate change. I agree with you. Both of those words are challenging, and skeptic, it is good to be skeptical. We should all be skeptical, and that is the reason that many people began to label the folks who were publicly challenging scientific evidence about climate change as not skeptics, but deniers. That's exactly what they were trying to do, was to reframe the whole discussion. They aren't being skeptical, they're denying the evidence. And so I think that was one attempt. We can argue about how successful that's been. But I think one of the best commentaries on belief was the response that Katharine Hayhoe has given recently, when she was asked if she believed in climate change. And she said, no, it's not a belief, it's a fact. And I think that is, so that plays to your, to your point. But words are tricky, and there are so many instances in which scientists use a word and mean one thing, and the public uses a word and means something totally different. And so that's part of what we need to understand is what do others hear when we think we're saying X? And we need clarity around the language that we use, which is to your point. So thank you. Yes?
Maria Hatziola, submarine ecologist working in international development. Thank you for a great talk, Jane. My question, or actually comment, is something that we've heard a little bit about on the margins, but it really is this whole issue of the politicization of science, and particularly here in Washington, where we're hearing, you know, how science is treated in the election or the lack thereof, but big money who has co-opted science, the amount of false science or faux science that is out there, the ability for people to, the public, to access information on the internet which is not valid, but which forms their belief system or colors their interpretation of what's going on. And there's, I really truly believe that it's a huge issue and that it has to do with the diminishment of the integrity of science and how people perceive science and scientists. And so my question is, you know, I'm not so worried about the federal government and policies within agencies. It has to do with big money that is able to co-opt science for its own goals, and how politicians who are supported by that big money are using their position and their influence to change the perception of science. So I wonder if you have some ideas about how to address that.
Thanks, Maria. That really is a huge problem. I couldn't agree more. I don't have all the answers to that. What I can tell you is that many people that I encounter who are not scientists are genuinely curious about things and don't know whom to ask, don't know whom to trust. And so I think that despite the cacophony, despite the availability of information, much of which is false or incomplete, I think there is more openness to facts and evidence than is often satisfied, in part because people don't know where to go that they can trust. And that's not just institutions, it's somebody, it's some person. So figuring out how to be seen as being trustworthy and how to engage, this is the engagement with society part that I'm talking about. I don't think that's the whole answer, because we have to solve the money problem that is causing all this disinformation. I don't have the answer to that. It's a real problem. But I think part of the solution, not all the solution, part of the solution is having scientists more engaged with society so people know where to go and whom to ask when they have questions. I can't tell you, I often wear a lot of ocean-themed jewelry, partly because I like it, but you do too, I know. But I can't tell you how many people just come up to me and say, you know, is it safe to eat seafood? What kind of seafood? How do I know what to eat and what not to eat? And that's just, one small thing. But then, you start talking about climate change. Well, I wondered about that. What is this? What is this? And so, I think there is this finding trusted advisors with answers that aren't trying to cram something down your throat is a huge opportunity. And we need to figure out how to solve that. Yes?
Hi, Jane.
Hey.
Ariana Settengreer, University of Maryland and NOAA. So I think I have tried very hard to take to heart a lot of the messages you had in your talk tonight about interdisciplinary science and use-inspired science in my own career. And what I am finding to date is that makes me highly unique, which could be a good thing, but what it really means is it's hard to sometimes find a fit in agencies, in academia, in
Yep.
other organizations.
Yep.
So I'm wondering what we collectively in this room, what AAAS, what agencies and academia can be doing to facilitate those of us who actually want to do a lot of what you're talking about, but then it means we don't fit a traditional career mold, and some of us are finding that very challenging. Thoughts on that?
Well, thank you for continuing to do that. And I fully agree. It is a challenge. It's a challenge for funding. It's a challenge for identity. It's a challenge for places. I am reminded, though, of the challenges that we had a decade ago in anybody doing any kind of interdisciplinary research that married natural and social sciences. that was next to impossible. And we've made huge headway in doing that. And I think it takes scientific leaders, it takes organizations, and it takes shining a spotlight on the problem and creating some new pathways and new identity. The funding, and the same is true for communication. Everybody says, yeah, training scientists, communicating scientists, great idea. Nobody pays the money to do it. And so, there are multiple things that we have to figure out as a community to make some of these suggestions operational. But keep plugging away. Jeremy.
Make this the last question.
Okay.
Jeremy Berg, Science Magazine. A minor editorial quibble for discussion.
Yes.
Your title. So its rightful place. I mean, I think one of the other problems scientists have is a perceived sense of arrogance or entitlement. And I think rightful somehow conveys a value judgment that it's our rightful place, we're entitled to have that place, and it's really an earned place because science tends to get answers that are true and useful because they're robust and they stand up when you push on them, as opposed to belief-based systems.
Yep.
So I think that's another.
Yep. How about appropriate?
Appropriate, proper, something like that. But I think the word humility, I think, is something that's really important in your talk, because I think that's another place, at least my interactions, where we lose people because scientists tend to come across as arrogant and know-it-all-y and everything else instead of engaging in the...
And entitled.
Right.
Jeremy, you're absolutely right, and that's a good editorial. So thank you for taking the job that you've taken, and we are delighted to have you at the helm and really look forward to what you're doing. So thank you all so very much. I appreciate it.
So I think what Jane was saying, you can expand that into an editorial, and we know where that could be published. Well, thank you all for coming. You're a good audience, and again, without a touch of arrogance, we're saying this is Jane Lubchenco's rightful place here at AAAS. We want to thank, again, the law firm of Cleary Gottlieb. We want to thank the Barnard the Lecture Selection Committee. And I'd like to also thank Olga Francois and Barry Williams, who put all this together for the Science and Technology Policy Program. Thank you all for coming. Now, we do have a catered reception outside for you to share these ideas and sharpen your thinking on how we will engage. Thank you.